Right. Welcome. Here in this lesson, I'll try to explain the how to interpret the phylogenetic tree diagram. Right. As you know, a phylogenetic tree diagram, it shows the evolutionary relationship among different species who are believed to have originated from the same ancestor. As you can see here, we have 1, 2, 3, 4, 5, 6, 7. There are 7 species. All these species, you can see, they all actually share the same lineage, right? They share the same lineage. So hence their ancestor is the one that is below, who is believed to be 6 million years ago. Because as you can see that as the geological timeline actually moves up, the numbers are decreasing, meaning that this gives us the present time, right? And this one is the primitive. So what do I mean when it's primitive? These are the oldest, right? So in this case, as we move up, we are moving from the primitive into the present. So which organism in this case was the first to evolve? Definitely it was the 7. Can you see 7 there? 7 was the first to emerge there. Then because he is the oldest common ancestor. So the common ancestors in this case, it's where speciation took place, which is A, B, C, D, E, and F. These are the common ancestor. So the one that is below there, say 5 million years ago, at A is the oldest common ancestor. Now, as I've indicated that as you move up, it means we are moving to the most recent. So now in this case, who is the most recent? Certainly, if you draw the lines that joins each common ancestor to the geological timeline, you discover that F is the most recent, is in most recent time. If this is 1 year, it means F is less than 1 year. Somewhere there you can actually find, they can read the scale there. I'm sure your mates can help you in this regard. So the second most recent is E. Can you see that? Like I've indicated. So now this is very important. Now the other thing that you must understand is that when you look at these species, all of them, they share the common ancestor, but they are different in terms of their closeness. Now let's look at which organism is most closely related to number 2, is most related to number 2. In other words, you actually, if you look at 1, 2, and 3, these are the closely related. But which one is most related between 1 and 3 to number 2? Now here you have to go back to where speciation took place. So speciation took place at D. So D is the common ancestor of 2 and 3, which is the most recent. So this one here is most recent than C. C actually is the common ancestor for 1, is the most recent common ancestor for 1, 2, and 3. But who is much more closer to number 2? Definitely you cannot say 1, because if you look at the geological time, this D actually is a timeline. It comes somewhere there, which if you read the scale, it gives you something like maybe say 1.6, 1.7, somewhere there, million years at which their common ancestor actually appeared. But what about C? C actually you can see is 2 point something. This one is 1 point something. This one is 2 point something. So which one is the most recent common ancestor? In this case, D is the most recent. I guess this actually makes sense. Now let's look at who is the most recent common ancestor closely, or the most close relative of number 4. Can you see that? 4, 5, and 6, they are all related. But who is the most closely related member? Definitely, you follow the same way I've actually explained 1, 2, and 3. So in this case, 5 is the most closely related to number 4. Does it make sense there? So 7 is by far related to 4, 5, and 6, because as you can see, their common ancestor is at number A, which is not actually connecting 4, 5, and 6 directly. So you can see that this one is all alone. I hope this actually makes sense in this case now. Thank you.